Greetings of the day, dear students. In this video, we are going to discuss about the principle of operation of DC generator. DC generator is a machine which converts the mechanical energy into electrical energy. Right? It is based upon the principle of production of dynamically induced EMF. That is, whenever a conductor cuts the magnetic flux, the dynamically induced EMF is produced in it according to the Faraday's law of electromagnetic induction. Now, this EMF will cause a current to flow in the conductor if the circuit is closed. Coming to its direction of induced EMF, it is given by the Fleming's right hand rule. Clear? Now, the essential components of the generator will be the magnetic field, conductor or some group of conductors, and the most important thing is there must be the motion of conductor with respect to the magnetic field. How do you understand that? For example, in between the poles, north pole and south pole, even though there is magnetic field, if the conductors are not moving or not rotating, if they are stationary, then there won't be any EMF induced in it. Similarly, if there is no magnetic field and simply if the conductor is rotating conductor is rotating and but there is no magnetic field, then also there won't be any induced EMF in it. Clear? Now, if you observe, let me consider one simple loop generator, right? Where we are having north pole and south pole, right? And this is ABCD is a coil, rectangular coil, and which is rotating on its own axis in the presence of the magnetic field. And now this magnetic field can be provided by either permanent magnets or some electromagnets. If we observe, these two ends of the coil are joined to the slip rings R1 and R2, and those are insulated from each other. And B1 and B2 indicates the carbon brushes. B1 and B2 indicates the carbon brushes, right? And these brushes will be pressed against the slip rings in order to collect the induced current, current induced in the coil, and to pass that current to the any external load connected. Clear? Right. Now, depending upon its rotation, the coil sides AB and CD, they will be changing continuously. Because of that, some EMF will be induced in the coil, which is given by E equals to minus N into d phi by dt. If we observe, the induced EMF is proportional to the rate of change of flux linkages. With respect to the different positions of the coil, we are having the possibility of this coil to get rotated from 0 to 360 degrees. 0 to 360 degrees. Whether it is at 0 degrees or some 45 degrees or 90 degrees or 180 degrees, at a different angle position with respect to the magnetic field, the EMF will be induced. From this graph, we can observe that at position 3, the induced EMF is maximum. That is at 90 degrees. 90 degrees is the angle between the magnetic field and the conductor. At that position, if you observe, the magnetic field induced is having a positive peak. Similarly, at 0 degrees, we are having minimum value. And again, at 180 degrees, we are having one more. Again, it is crossing the 0. And 180 plus 90, 270 degrees, we can observe we are having a negative peak. We are having a negative peak. Like this, at different positions of the coil, with respect to the magnetic field, different magnitude of EMF will be induced in the coil in one cycle, within one rotation, 0 to 360 degrees. Clear? Now, on observing this waveform, we may get a doubt that the generator is DC generator, but the waveform we got is sinusoidal in nature, alternating quantity. Now this AC will be converted into the DC with the help of a device called commutator. A commutator, this is the device which converts the generated AC into the DC. We can call this commutator also as a mechanical rectifier, mechanical rectifier. Clear? Right. So in this entire discussion, the important key points are DC generator is a device which converts mechanical energy into electrical energy, and the principle of production, it is based on the principle of production of dynamically induced EMF, right? And this dynamically induced EMF is produced according to the Faraday's law of electromagnetic induction, and the direction of induced EMF is given by the Fleming's right hand rule, right? And the important thing is there must be the motion of conductor with respect to the magnetic field. These are the important key points, and these are to be highlighted while attempting a question from this, while attempting the question on this topic, right? Thank you.